Good morning, everybody. Today we're going to be doing a review of everything that we've learned in the third grade. Okay, so I need you to grab your marker board and a marker, and we're going to review all of the math that we have learned in third grade. So we're starting with Module 1, okay, and that's where we were learning about multiplication and division. That's where we learned scram. So let's look at some of these questions that Eureka has for us. Mr. Lewis arranges all the desks in his classroom into 6 equal groups of 4. Because this took me so long, I went ahead and I just kept it on here. How many desks are in his classroom? Show a picture in multiplication sentence in your work. Okay, so here's my picture. Like I said, it took forever, so I didn't want you guys waiting on me to drop each little circle. It says there's 6 equal groups of 4. So I did 6 and I put them in 4 columns. So I have 6 rows of 4, or I have 4 columns of 6. Now we know that it already says multiplication, but we would have known to do multiplication whenever it says 6 equal groups of 4, because we know that multiplying, all it is adding equal groups. So our multiplication sentence would be 6 times 4. And if you look over here, I have 6 by 4. This is an array. You could do cookie method if you wanted to. And then whenever I add up all my circles, I can count them by 4s. 4, 8, 12, 16, 20, 24. So my product is 24. So I've answered all parts of the question because I have a picture right here and a multiplication sentence. Check. All right, part A, what does the product in your multiplication sentence represent? Well, our product, remember, is the answer to a multiplication problem. So 24 represents the total amount of desks. Part B, fill in the blanks below to complete a related division sentence. So our unknowns are the dividend. Remember, the dividend works out in the den. It's our biggest number. Which one of these is the biggest number? 6, 4, or 24? Well, we know it can't be 4 because 4 is already used as our divisor. And we know 24 is much greater than 6. So we know 24 would be our dividend. Division problems always start with the biggest number. So now we have 24 divided by 4, and the number that we have left is 6. 6 is called the quotient. It's the queen. It's the answer to a division problem. Speaking of quotient, part C says, what does the quotient in part B represent? Well, we know our quotient is 6, and 6 represents what? The equal groups. It says I have 6 equal groups. Okay, and that is our review for Module 1. So go ahead and erase your boards. Moving on to Module 2. Telling time. For some of you guys, you didn't like telling time. For others, you loved telling time. So that's what we learned second. Let's look at what we have. It says the clock to the right shows what time it is now. Okay. Estimate the time to the nearest 10 minutes. Well, first I'm just going to be able to tell what time it is. Let's see. It's just right past the 10. So the first hand that I read is the shorthand. So I know it is 10. Now I read the long hand. 10, well, 3 represents 15. So 15, I'm going to count each dot. 16, 17, 18, 19. So it's 10:19. 19 rounded to the nearest 10 would be 20. Very good. So it would really, the time estimated to the nearest 10 would be 10:20. So that would be your answer. Part B says the clock to the right shows Paul's departure time. Estimate the time to the nearest 10 minutes. Okay, so first we have to be able to tell the time. So let's zoom in. Now this one's tricky. Remember, whenever the minute hand gets on this side of the 6, the hour hand starts pointing to the next hour. It gets closer to the next hour because the hour hand never stops moving. Okay, so here, it's not quite on the 11, but it's really, really close. But it's past the 10. And we know that it's actually closer to 11 o'clock than it is 10, but we know that it is 10 o'clock. So your hour would be 10, and that's my shorthand. Now I move on to my minute hand. 10 represents 50 because these are groups of 5, and 10 times 5 is 50. Now I count each dot. 51, 52, 53. So the time would be 10:53, but it wants us to estimate the time to the nearest 10 minutes. What is 53 rounded to the nearest 10? 4 or less, let it rest. 5 or more, raise the score. Well, we're going to have to let this one rest because 3 is 4 or less. So really, this time would be 10:50. Part C, use your answers from part A and B to estimate how long Paul has before his flight leaves. So we have from 10:20 to 10:50. How much time is in between 10:20 and 10:50? Very good, 30 minutes. You know this because 50 minus 20 is 30. 30 minutes is also half an hour. Okay, so in Module 2, you also learned subtraction, 3-digit subtraction. So I thought we could do some subtraction problems together. So go ahead and erase your board. The first subtraction problem we're going to look at is 423 minus 189. So let's do it. 3 minus 9 is, got more on the floor. I got to go next door. My 2 becomes a 1 because I took 10 from it. My 3 becomes a 13. 13 minus 9 is 4. 1 minus 8 is, got more on the floor. I got to go next door. My 4 becomes a 3. My 1 becomes an 11. Good, because 10 plus 1 is 11. 11 minus 8 is 3. 3 minus 1 is 2. I can check my answer by doing 234 plus 189. 4 plus 9 is 13. 8 plus 3 is 11, plus 1 more is 12. 2 plus 1 is 4. So everything checks out. I know my answer is correct. All right, next problem. We have 600 minus 438. Now, whenever it comes to a number that, like 600, 500, 300, a multiple of 100, you can technically change 600 to 599. So take away 1 from it. And then you have to take away 1 from this number too. So that would be 437. So there's 2 ways to do it. We'll do this way first. This makes it to where you never have to regroup. So you have 9 minus 7 is 2. 9 minus 3 is 6. And 5 minus 4 is 1. Okay, let's see if that works over here. 0 minus 8, can't do it. Got more on the floor. I got to go next door. But my next door neighbor is broke. So I'm going to look at this as an entire number, 60, and I'm going to make it 59. Now this 0 now becomes a 9. No, wait, it doesn't become a 9. Just kidding. It becomes a 10. I don't know what I was thinking. So now we have 10 minus 8 is 2. 9 minus 3 is 6. 5 minus 4 is 1. Let's double check our answer. Okay, so we do 162 plus 438. 8 plus 2 is 10. So that's 6 plus 3 plus 1. Well, 6 plus 1 is 7, plus 3 is 10. 4 plus 1 gets me 6. So it all adds up. All right, next problem. 2 minus 9, can't do it. Got more on the floor. I got to go next door. My 6 becomes a 5. My 2 becomes a 12. 12 minus 9 is 3. 5 minus 5 is 0. 7 minus 2, got more on top. No need to stop. 7 minus 2 is 5. We'll double check our answer by adding what we took away. 9 plus 3 is 12. 5 plus 1 is 6. And 5 plus 2 is 7. 762, 762, 259, 259. It all checks out. All right, now we're going to move on to Module 3. Module 3 is what you learned in January. It's where we were able to label the unknowns with letters. So we got into some algebra. So let's start off with Aunt Karina. You might remember this from your Module 3 test. It says Aunt Karina and her 3 friends decided to share a cab to go to the mall. If they each spend $6, how much did the cab ride cost altogether? Write an equation using a letter to represent the unknown and solve. Okay, so Aunt Karina and her 3 friends. So how many people are actually going to the mall? 4. Very good. Don't let that trick you. You have to read the question carefully and visualize it. So you'd be visualizing Aunt Karina, and then she has 3 friends with her, so there's 4 people altogether. If they spend $6, how much did the cab ride cost altogether? So they're each spending $6. That's 6 equal groups of 4. So I know I have to do 6 times 4. And rather than go ahead and putting my product, it says write an equation using a letter. Well, I always choose the letter M because my name starts with an M, but you can choose whatever letter you want. Then it says solve. So we'd have 6 times 4 equals M, and then you'd put M equals 24. All right, number 2. Aunt Karina's 3 friends each order pasta and a lemonade for lunch. Okay, so we have our menu over here. Aunt Karina's 3 friends, they order a pasta plus a lemonade. But Aunt Karina orders only a chicken salad. Okay, use the menu to find how much they spent altogether. So Aunt Karina's 3 friends got a pasta and a lemonade. Okay, a pasta and a lemonade, 7 plus 2 is $9. So her friends spent $9 for lunch, and there were 3 of them. Okay, so we know that we would write 3 times 9, and we can put that in parentheses because we've got to add Aunt Karina's lunch in there too. And we'll make a whole different multiplication problem over here. It says Aunt Karina orders only chicken salad. Well, there's just one of Aunt Karina, so it would be 1 times, let's find out how much chicken salad cost, $9. Now we can combine these two. Since our last factor is the same, you can keep this factor the exact same. And you can combine this, 3 and 1. So technically, instead of putting 3 times 9 plus 1 times 9 equals M, you could put 4 times 9 equals M, because there are 4 people altogether, and they're each spending $9. Then it wants me to solve for the letter. So I would do M equals 36. Now we even put dollars. Okay. Part B. Aunt Karina mentally checks the total using 4 times $9. Explain her strategy. Wow. Aunt Karina, we were thinking the same thing she was. Great minds think alike. So explain her strategy. I need to restate this question. I would say Aunt Karina used the strategy of 4 times 9 because there were 4 people. Make that a little bit smaller. 4 people, and they each spent $9. So that is 4 equal groups of 9. There you go. That's all multiplication is 4 equal groups of 9. All right, now we're moving on to Module 4, which was area. Okay, we learned about area in February. It says Mr. and Mrs. Jackson are buying a new house. They are decided between the 2 floor plans below. Okay, it says which floor has the greater area, so which house is bigger. Show how you found your answer on the drawings above and show your calculations below. Now notice how these houses aren't a perfect square, so they are going to take us dividing them up into rectangles and squares and being able to find those parallel lines that correlate to know how big the rectangles are. So the first one, we could do a subtraction of area or we could do addition of area. So I'll do both actually. So what we could do is this side is 10. I'm going to go ahead and close this and I'm going to make it 10. Okay. Now it's really easy. All the house is a 10 by 12. I know that this side is 12 because it's got parallel lines, 12 and 12. Well, 10 times 12 is 120. But we're not done there because it's missing this giant chunk. So we now have to subtract this big chunk. So we need to find what the area of this is. Well, if this is 6 and this whole line right here is 12, what is this line? 6. Very good, because 6 plus 6 is 12. Okay, if this is 3 and this is 4, that's 7, and this whole thing has to be 10. I know that this side's actually 3. Good. So I do 6 times 3 to find the area of this, and it's 18 meters squared. So now I have to subtract that. 120 minus 18, and that gets me 102 meters squared. Now, if you don't like the subtraction way to do it, you can divide this house up into 3 rectangles instead. So let's take a look at that. So here's a rectangle, okay? So it's a 3 by, we know that this side is 12 because it is parallel to this side. And 12 times 3 gets you 36. So this part of the house is 36 meters squared. Okay, and then right here we can divide this shape up. This would be a 6 by. Well, this line correlates with this line. They're parallel. And I know that my missing side, if I have 3 plus 4, that's 7. 10 minus 7 gets me 3. So this side is 3. So I do 6 times 3, and that would get me 18. We also know that this space is the exact same as this space, and we just solved that. So this would be 18 meters squared. So then now we have this rectangle we need to solve for. So it's a 12 by 4, and 12 times 4 gets you 48. Now we just add all the areas together to get the total area. So 36 plus 18 plus 48. So 8 plus 8 is 16. 16 plus 6 is 22. 3 plus 1 plus 4. Well, 3 plus 1 is 4. 4 plus 4 is 8. 8 plus 2 is 10. So we get the same answer whether we want to add in all the areas or whether we do the subtraction method. So this house, house A, is 102 meters squared. Now we got to figure out how big's house B, because we got to figure out which one's bigger. So let's do this. This one's got so many cutouts. Let's just go ahead and add these all together. We could subtract it, but it'd be way harder than adding it. Oops. Try that again. This is a 3 by 3. 3 times 3 is 9. Okay. So now don't get tricked here. This whole thing it's saying is 10. And over here it says this part is 4. And this part is 3. So picture an imaginary line. This has to go across right here. This has to go all the way across, and it's got to be 10. So if this part's 3, this part's 4, how big is this part right here? Very good. It is 3. Because look, 3 plus 4 gets you 10. So I'm going to divide this up. So I have 3 meters this way right here. Oops. Right here's 3 meters. And then going this way, it says this entire thing is 12 But we got to take away 3 because it's missing that. 12 minus 3 is 9. So now we know this rectangle is a 9 by 3. So you got to use your hints and you got to infer and try to figure out what your missing sides are. So now you have 9 times 3, and that gets you 27 meters squared. Okay, now your bottom rectangle is left, and it's really easy to solve because it already has the numbers there. This side's a 4. Okay, that's your length. And then your width is 12. So 12 times 4, we just found out, is 48. So now we got to add all these together to see if it's going to be greater than or less than 102. So 9 plus 27 plus 48. Okay. 8 plus 7 is 15. 15 plus 9 is 24. 4 plus 2 is 6. 7, 8. This house is 84 meters squared. So house A is greater than house B. It says which floor has the greater area. Show how you found your answer on the drawing above and show your calculations below. So I would write house A has the greater area. I know this because I should see a lot of I know this because on your K-Prep test. I know this because the area of house A is 102 meters squared. I found this answer by adding 36 plus 18 plus 48 to get a total area of 102. House B has an area of 84 meters squared. I know this because I added 9 plus 27 plus 48 to get a total area of 84 meters squared. I know that 102 is greater than 84, so the Jackson family, because we're referring back to the very top, should buy house A. Now that is a distinguished answer, folks, right there. That's what I'm expecting when I walk around. This is a popsicle answer if I've ever seen it. Okay, I've referred back to the family. I said I know this because I gave the equation that goes with it. And I even talked about how this one is greater than this one and how I knew that. Okay, so now we're moving on from Module 4 to Module 5, which was fractions, which is what we just learned. So let's look at this fraction. We learned all about Jerry on Module 5's assessment. Okay, Jerry and his son have the exact same granola bar. Jerry has eaten 3/6 of his granola bar. His son has eaten 3/8 of his own granola bar. Who has eaten more? Explain your answer using words, pictures, and numbers. Look at this part. Words, pictures, numbers. If you only use one of these 3, you have not answered the whole question. So you have to do all 3 things. So what I'm going to do is I'm going to draw 2 identical granola bars. There we go. So this will be Jerry's. I'll make a J for Jerry. And then J, Jerry's son. Why did I put an apostrophe S? Because it's a possessive noun. He owns his son. It's Jerry's son. Okay. So Jerry's has his granola bar broken into 6th because the bottom number is how many pieces there are total. All right, so let's break it into 6th. I always break it in half when it's an even number, and then from there, I think what plus what gets me 6? 3 plus 3 gets me 6. So I broke it in half, and I needed 3 on each side. All right, then it says his son's eaten 3/8. So I'm going to do the same thing. 8 is also an even number. I'm going to break it in half here, and I need it in fourths, each half in fourths. Okay, who is eating more? So now we got to color them in. I'm going to use a different color. Okay, there's 3/8. Oops, I can erase that. And then here's 3/8, and at the top there's 3/6. Okay, we can clearly see that 3/6, which is half of the granola bar, is larger than 3/8. It says who is eating more. Okay, so we've got our picture. Check. Now we need our words and our numbers. So our words would be Jerry has eaten more of his granola bar. I know this because 3/6 is greater than 3/8. Okay, so I use, all right, it says it wants me to use numbers. Okay, you can talk about how when the denominator is bigger, that means there are more pieces and the pieces are smaller. Our numerator is the same, so I knew Jerry ate more. All right, so I've got my numbers in here with 3/8 and 3/6. I've got my words, and then I have my picture that I drew. So I answered all parts of the question. Check, check, and check. Okay. And we have a couple more. Okay, now this was Module 6, and I just want to quickly go over it. Some of you guys did Module 6 for 20 dojo points. Some of you guys didn't. All Module 6 was 9 lessons, and it was all about reading graphs. So here's a graph. Okay, it says a picture graph below represents all the trees in the park. And each of these pictures, so they're maple. There's 3 maple trees. Spruce. Spruce has 1, 2, 3, 4, 5, 6. Okay, birch has 7. Oak has 1, 2, 3, 4, 5. And ash has 4. So you'll find the name and then the tree that represents it. Now look, it represents 4 trees. One of these trees does. So even though there are 3 trees here, you have to pay attention to this key. Okay, so 3 trees, 3 times 4 actually gets you 12. So be careful with that. So spruce, that would be 6 times 4, which gets you 24. So I'm just going to go ahead and put however many trees there are to help me not get confused. Birch has 7. 7 times 4 is 28. Good. Okay. Oak, 1, 2, 3, 4, 5 trees, and the 4 trees represent one of the trees. So 5 times 4 is 20. 1, 2, 3, 4, 4 ash trees, and there are 4 trees together. So that represents 16. Okay, so that just makes it easy for me to read. Part A, use the grid to create and label a scaled bar graph representing the data in the picture above. Okay, so I went ahead and paused it just so I could label these and you guys don't have to wait on me. So we have a grid right here, and I went ahead and I put all the types of trees at the bottom. So maple, spruce, birch, oak, and ash, just like they did up here. And I'm going to go every other with these to represent the bar. Now on this side, I'm going to need to put all my numbers. Okay, and they have to be in multiples of 4 because each tree represents 4. No, I'll work my way from the top. Well, the biggest one is 28. So let's just go 4 more up from that, and that would be 32. So let's do 32. Then we can do 28. And down from that, 24. Let's see. Hope this all fits. And 20. 16. Minus 4 is 12. I might have to take out these. Okay, minus 4 would get you 8. Minus 4 would get you 4. Okay. Oh, that's not going to work either. Okay, just kidding. Okay, I'm sorry. I just wasted like 30 seconds of your life because I couldn't get these numbers together. So when I went ahead and paused the video and then I labeled it drawing the numbers. Okay, so it goes from 0 to 32 like we wanted it to. All right, now we've got to represent these bars with what we have up here. Okay, our picture graph has the pictures to represent. So now we have to represent it with a bar. So we know that there's actually 12 maples. So we're going to go all the way up to 12 and we're going to color this in. I've got to be real meticulous about the way that I do this so that I don't color outside the lines. Okay, then we have spruce has 24. So I go all the way up to 24 right here underneath spruce. And I'm going to color all the way down. All right, and then we have birch, which has 28. So we're going to color all the way down again. Oak has 20. Find 20, which is right here. I color from 20 all the way down. And then ash, which is 16. Find 16, color all the way down. Okay, and there's my bar graph. Now it says, how many more apple and oak trees are there than birch? Well, how many more maple and oak trees? I don't know where I got apple from. Maple and oak trees. Well, there's 12 maple. And there are 20 oak. Okay, so 12 plus 20 is 32 total. And it says, how many more are there than the birch trees? So I need to subtract how many birch trees there are, and there's 28. So I'd do 32 minus 28, and that would get me 4. 4 more trees. So I'm going to write that in words. There are 4 more maple and oak trees than birch trees. Period. Okay, and that would be our module 6. So now we're going to solve what we've been working on right now, and that is perimeter. So erase your boards. All right, so it says Katie and Jane built a square fence around the castle's pool. It has a perimeter of 36 feet. What is the area that the fence encloses? Use a letter to represent the unknown. Show your work. Okay, so it has a perimeter of 6 feet. A perimeter of 36 feet. What is the area? Well, it's a square fence. So what times what gets you 36 and it has the same factors? The factors have to be the same because it's a square. So think on that. What 2 numbers are the exact same to get you 36? Okay, just kidding. I was thinking about if it was an area. Okay, this is I was talking about if it has a perimeter. So perimeter is whenever perimeter is around, you add up all the sides, Okay, so the perimeter is 36. You can tell it's the morning. I keep messing up on everything. Okay, so 36 feet. So now it wants to know what the area is. So what plus what plus what plus what is going to get you 36? So it has to be the same number because it's a square like we were talking about. Well, and we're adding them 4 times. So pretty much you could think about it as 36 divided by 4 because all multiplication is repeated addition, and a square has the same sides. So this has to be the same number every single time. So what's 36 divided by 4? 9. Good. So let's double check that math. If this was 9, so if we did 9 plus 9 plus 9 plus 9, 9 plus 9 is 18. 18 plus 18 is 36. Okay, so now we know what the side links are because we're given the perimeter. Now we need to figure out what the area of the fence is and use a letter to represent the unknown. So, well, to figure out area, it's just length times width. Length times width. So that is 9 times 9 equals m. And then we want to go ahead and solve for m. M equals 81. 81, let's see, feet squared. And there you go. So it's all together, there'd be 81 squares within this. And then all the way around, there are 36 squares on the edges. All right, last question. It says, suppose each square is 1 square centimeter. Part A, find the area and perimeter of each shape. Well, perimeter is just the outside of this figure. Okay, so how I like to solve perimeter is I like to I could just count up all of these. So I'm going to use the laser. So really, I can just go around the edge of the shape. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. I'm back to where I used to be. So our perimeter equals 20. Because this was 4, you have 1, 1, 1, 1, 2, 1, 1 on this edge, 1 on this edge, 1 on this edge. Then you have 2 on this entire edge. And if you add up 1 plus 1 plus 1 plus 1 is 4, plus 2 more is 6, plus 4 more is 10, 11, 12, 13, 14, 16. 16 plus 4 is 20. So, yep, I'm double checking my work, and it is. The perimeter of this is 20. Now we have to find the area, and that's going to be easy peasy because all we have to do is add up all of the squares. That's all area is how many squares does it take up? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 centimeters square. And that's for this shape. Okay, now this shape, we're just going to count the edges. Okay, so the border is the perimeter. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So let's double check that. You never know. There's 3 on this side. There's 3 on this side. Okay, and then there's 1 going down, 2 across. 1 going down, 1 on the side, 1 on this side, 1, 2, 3, 4, 5, 6 on this side. 3 plus 3 is 6, 7, 8, 9, 10, 11, 12, plus 6 more. That gets you 18, so we're correct. Perimeter is 18 centimeters. Now the area is really easy because all we have to do is count up the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Area equals 14 centimeters squared. Part B, John says if 2 shapes have the same area, they must also have the same perimeter. Is John correct? Use your answers from part A to explain why or why not. Well, you tell me. We just looked at 2 different shapes who have the same area. We just found 2 shapes that had the same area, but did they have the same perimeter? No. So, John is incorrect. I know this because the 2 shapes in part A have the same area but have different perimeters. And there you are. And that is the end of everything that we have learned this year in math. Whew. I'm so excited. I can't wait for you to rock your test tomorrow. See you guys tomorrow.